All right, so thank you all for coming. This is the closest thing you would get from a title slide, because there aren't going to be any slides at all. So I'm just going to be doing some live coding today. All right, so let's begin. First of all, who ever heard about completable future? And it's actually relevant. Okay, most of you, so I'm just going to give you a very short introduction, not even an introduction. So a completable future is something that represents an asynchronous computation that happens in the background, right? So you have a completable future of a type, let's say, completable future of type string, and you know that you're going to get a string sometime in the future, all right? So let's make it completable future. And it's completed and it has a value of 42. All right, and what you can do with this one, you can basically assume that it's a future and you're going to get a value of type string sometime in the future, maybe within milliseconds, maybe within hours. And by the way, if you don't see fonts or if you have some issues with reading this, just let me know. There aren't going to be any slides at all, so it's very crucial that you actually see the code. And I would like to actually ask you to make questions during the talk when you have a question about some particular piece of code, because otherwise it might get lost with Slido and we're going to have to go back. So feel free to pop questions and we're just going to be coding it in real time, all right? Okay. So here we have a future, and what's really important about future, and this is really relevant for RxJava as well, what you can do is that you can actually say then apply, and what then apply does is that it takes whatever is inside a future, so in this case it's a string, so I'm going to make it really explicit here. So we have a string, and you can apply some transformation on top of that string. So for example, you can say length plus 1. And what is really important is that the type of this expression is a bit unusual. So what's it going to be? Do you know? Many of you said you know completable future. Yes, completable state or completable future. But what's really important is that you're not going to get an integer back. Even though this transformation is a transformation from the contents of the future, from string to integer, what you actually get is, whoopsie, what you actually get is a, if I ever get this extraction correctly, it's actually a future of integer, right? So yeah, here's a complete statement. And this is really important because what then apply does, and typically it's actually in every other language and technology, it's called just map. What then apply does is that it just applies a transformation on the contents of the future when this future is completed. So you're not blocking on the result. You're not waiting until you actually get this string. The only thing that happens here is that you're registering a transformation that's going to be applied later on. So believe it or not, this was a very short introduction into RxJava, because in RxJava this is very, very similar. So let's say you have, well, in RxJava you actually have an abstraction called observable, and in RxJava 2 there's another one called flowable, but let's keep it simple. So you have an observable, let's say of string, to make it similar. And this observable represents a stream of data. So a completable future, in some sense, is a stream of data as well. It's a stream of a single value. So you know that you're going to get a single value in the future. With RxJava, you actually get a stream of future values. So you're going to get 0, or maybe 1, or maybe 10, or maybe an infinite number of events that's going to occur in the future. So for example, let's just make a dummy stream, call it observable, and just make it observable, whatever. It's going to return like 42, but also 43 and 44. So what's going to happen right now? This is a very dummy string because I hard-coded all the events. Typically, these events are going to be coming to you in some periods of time. So you're going to get one event, and milliseconds or maybe hours later, you're going to get a second event, and so on and so forth. But this is a very dummy string that we're just using here for an introduction. So what happens right now is that I can actually, for example, do a mapping, but it's not called then apply. It's called map. And what mapping does is that you can apply a transformation on top of every event that flows through this observable. So we can build pipelines that are transforming data on the fly. And map is actually the simplest operator. You have filter, you have reduce, you have buffer, window, and so on. There are actually tons of operators. So if I can just start from the very beginning, I think there's more like 100 different operators that are doing some really interesting stuff. For example, replay, that, or actually maybe repeat, which is here, that basically what it does is that it allows you to take a stream that has completed and then repeat everything that was in that stream. We can actually check it out, actually. So I can do map And inside this map, let's do the same transformation. So from a string to its length. And what's the type of this expression? Of course, so it's observable of integer, right? So I'm going to keep it this way, and then I'm going to say, or actually I'm going to just repeat it. So observables are actually immutable. So even though I ran a .map on an observable, this original observable is still usable and it wasn't like modified in any way. So I can apply different sets of transformations on the same source. So I have like one publisher, and then I can apply different transformations on top of it. I'm going to do my best to actually write on the top of the screen. All right, so let's write it again. So I can say s length something, then I can do filter. And here's my string, and I can do, or actually, now I have integers, right? So now I can say x must be equal to 2. I happen to know that all strings have length of 2, so let's make another one, like 4, 5, 6, for example. So this one's going to be rejected because its length is different. And then I can say repeat 3 times, all right? And this altogether is still an observable. Just to make it more complex, I'm going to squish this thing. So let's make it x times 2.0. So what's the type of this huge expression?
Double.
No, it's not a double. If it was a double, then first of all, you have 4 input values. So which double would it be? You would have to get a list of doubles or something like that. And this would mean that you would have to block. And RxJava is all about reactive things. So you have an observable of double. Let's call it repeated. And the thing is that as long as I don't subscribe to an observable, and we'll get to that in a second, as long as I don't subscribe to an observable, nothing's going to happen. So these callbacks aren't really executed. They are lazy. They are postponed until actually the fact that I'm interested in the data. So and as long as I don't do subscribe, and more on that in a second, no logic was invoked yet. So let's subscribe and let's just print it. So I'm going to make a simple helper method, which is going to be useful later on. Got an object, all right? Okay, and I actually need a logger, so let's put it here. Okay, so what I can do here is that here I'm receiving doubles, okay? So I have doubles, and for each double, I want to actually print them. I know I can use a simpler syntax, but I just want to make it like very clear for you. Okay, so here's my sample, and since it's live coding, there should be live running as well. So let's run it, and what we got here is that 4, 4, 4, 4. Okay, this is really dummy because, well, let's just trace it. Why do we have these results? Or maybe what's going to happen, I'm just going to make different strings here to make it a little bit more interesting. And rather than equals 2, I'm going to make smaller than or equal to 2, okay? So here's what happens. First of all, I'm turning every string into its length. So first of all, I had strings of this, 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 and this, and then I have a stream of 1, 2, 3, and 4. These are lengths of consecutive strings. I'm just going to run it so that you can follow along. Then I'm filtering out all the numbers that are greater than 3. So I no longer have this string, for example, these two actually, because I'm only interested about the first two. So I have string of length 1 and string of length 2. Then I'm doing this transformation, which maps from, which basically multiplies by 2, and then I'm repeating it. So let's remove this one first. Well, actually, it won't compile anymore. It won't compile because here I have a different type. Okay, still it works. So if I run it now, I'm just going to get 1, 2, 1, 2, 1, 2, and these are the lengths of this string and this string. And I have it multiple times because I basically said repeat 3. So that was a very gentle introduction to RxJava. Any questions? Alrighty then. You can use Slido as well. We're going to jump into them later on. Okay, so this is RxJava. This wasn't very entertaining, but let's just jump into something a little bit more realistic. So I happen to have a bunch of classes that I would like to show you. Let's start with a weather client. So here we have a class that pretends to be a weather client. So all it does is that it sleeps for a bunch of time, from 900 to 950 milliseconds, and then it pretends to be returning something over HTTP. I mean, it's as simple as it can be, and it's blocking. So let's make this method RxJava friendly. Well, the only thing I'm going to do is I'm going to wrap a return value with an observable. And obviously, it no longer compiles if I just say, I have to change the name of the method. Obviously, it no longer compiles if I just say return fetch city, right? Because this one returns weather, and I want to return observable of weather. So I have to like do something with it. So what I can do, and this is the simplest thing, is that I use a factory method called fromCallable, and fromCallable takes an argument of type callable. So here I'm supposed to, you know what, I'm just going to make it explicit for the first time. Okay, it's a lot of code, but we're going to simplify it in a second. So fromCallable takes a piece of code, a lambda expression actually, and wraps it wrapped in a callable and puts it into an observable. What's really interesting about this part, I can simplify it greatly. What's really interesting about this one is that every time I call RxFetch, and let's just do it straight away. So new weather client, I'm going to put it here. Every time I call weather client with a normal version, the one that just do a blocking call, if I run it right now, just follow the terminal, you're going to see that it actually loads the weather, and it actually, after about almost 1 second, you get the result. On the other hand, if I call RxFetch, and I'm going to do it in a separate test, you know what? I'm writing code in an append-only fashion, which means I'll try to never delete any code because I want to publish the source code later on. So if you catch me on deleting some code or modifying code that I already wrote, just please shout, because that means I'm actually destroying something. So every single time I'm making any example, I'm just writing another one. All right, so here is our Rx version of the client, and just to remind you, the only difference is that I took the blocking code and I wrapped it in a callable, which I put back into an observable. And whatever this callable returns, whatever this lambda expression returns, is going to become a single event emitted from that observable. So this observable is guaranteed to emit exactly one event, or an exception if this throws an exception, which is not the case in this particular thing, but it can happen. All right, so we're calling this one, and let's just run it first. And the interesting part is that actually nothing happens. We got this observable, which is here, but as long as I don't subscribe to this observable, I'm not going to initiate any business logic. I think it went down, so I'm just going to turn it on and off, and it will work. So what happens? I think it works. Yay. Okay, so what's going to happen is that I can do subscribe, it's like a discotheque here. Whoa. All right. Any questions so far, by the way? Oh, yeah, it's not even a question. I can see it. Come on. All right, so what's going to happen right now is that I'm going to subscribe to this observable. I can still see it's blinking. Damn you. Okay, so I'm going to subscribe to this observable. And what's going to happen is that as long as I don't subscribe, no business logic is executed. So this lambda expression is not executed. But the moment it is, it will actually initiate the logic. And in the very beginning, it actually happens. I don't think it's blinking anymore. Okay, great. So as long as I don't, I saw this one. As long as I don't subscribe, nothing is going to happen. So here I'm subscribing, and this is the exact same class. Notice that everything happens basically in the same thread. So I have main thread that starts loading, then it's done, and then I got it. So by default, which is not really idiomatic, but by default, RxJava doesn't involve any threads at all. Everything just happens in the client thread, which means that this code, the subscribe code, is actually blocking. So, okay. And you will see that OK is actually triggered after the subscription got ended. So how would you go actually with having something asynchronous in RxJava? So imagine that, excuse me? No, not really. Publishing is a little bit more advanced thing. I don't think we're going to cover it today. But we're going to cover a little bit, very, very simple operators for concurrency. So the first one I actually want to show you, because, yeah, we actually wrote a lot of boilerplate without any particular gain. It's just much more complex at the moment. So let's start with our weather client. I'm just going to copy-paste it. This is not a good idea normally, but during live demo, it's great. So here we have our Riga observable. And let's assume that I don't want to wait more than 1 second for the response. So our response right now is something like between 900 milliseconds and, let's say, 1,100 milliseconds. So it's around 1 second. However, I don't want to wait more than 1 second. So what I can do, I can simply say timeout. Here it is, timeout 1 second. And then I subscribe to it. All right, that was simple. There are different timeout scenarios, but this one is like the simplest. So let's run it, and we're actually going to see, well, we're not going to see anything because I'm running a different one, I think. Yeah, so we have timeout exception, which was totally expected. And this happens because at this particular case, the weather client didn't return within a second. Maybe it will succeed. Yeah, this time it succeeded because it was slightly less than 1 second. I was really lucky here. So that's kind of the simplest operator we're going to see today. As you saw, that there are actually hundreds of different operators. We're going to cover like 90% of them today. So this was the timeout operator, but the thing is that how do you actually make RxJava asynchronous? Because timeout operator sort of does it, but how do you control concurrency? And it turns out it's just damn simple. If I fetch weather for Riga again, Rx fetch Riga, any other city that you particularly like?
No.
No, not at all? You just love Riga? Okay, so I'm going to pick Warsaw, which happens to be from where I'm from. So I have two observables. Let's just make them the same size because then it's symmetric. And now I want to get the weather for both of them, but I want to make it concurrent. So I want to fetch these two weathers at basically the same time. So first of all, nothing happened yet because I haven't subscribed. What I can do is that I can merge these two observables, and I'm going to explain in a second what that means. So I have another observable let's call it both. And what happens right now is that when I have two observables and I merge them, it basically means I get one observable in return that gets all the events from the first observable and from the second observable. So it's like joining two streams of data in a safe and concurrent manner. So in this case, we can expect that both will actually emit two events. Yes?
But they need to be the same type, right?
Yes, exactly. We can cover this case as well if we have some time, if they are different type. But that's a very good question. So both of these observables have to be of type weather, because otherwise you would get streams of different types, which is not type safe. Yes?
You can always just map existing observables.
Yes, obviously. Yes, so if this weather was from a different type, I could do something like toWeather or something, right? So that's perfectly possible. But we are lucky and they are of the same type. All right, so everything still compiles. So what I'm going to do is that I'm going to subscribe. And the thing is that obviously I can still apply timeout operator here. I don't because it's not useful in this particular case, but I can still do it. So the interesting part is that since RxJava is by default synchronous, we don't get any concurrency. You see everything happens in the main thread. This is the first observable, and this is the second observable. Absolutely nothing happened with threads. Everything happened in the main thread, which is actually a good thing. Observables are much richer than the stream API from Java 8, which means that very often you're going to find yourself using observables just because they have a richer set of operators. They have windows, they have skip while, take while, and so on. All this stuff that's actually missing in Java 8. So it's actually quite useful to turn a list or a set into an observable and then go back to a list. Yes?
Sorry, why was the name of this talk about legacy project?
We're going to get into that. So this is not an introduction. I just want to show you like more common examples. All right. And well, that's also the thing I want to show you. How do you interact with? How RxJava interacts with a code that already exists, like the weather client. And we're going to get into some enterprise integration in a second. Alrighty then, so let's run it. And we see that there is no concurrency yet, so let's just put it in a very, very pluggable way. So here's our observable. And the simplest way of applying concurrency into an existing observable is basically saying subscribe on and putting on a so-called scheduler. So a scheduler, I think it's schedulers.io, you can pretend that it's a thread pool. It's a little bit more complex than that, but you can assume it's a thread pool. I/O is not a particularly good case for production code. I'm just going to use it during demos because it's the shortest one. So the name is the shortest, so it's going to be very useful for me. So what happens right now, remember that both of these observables are now using the subscribe on operator. So if I run it right now, I'm actually going to get concurrency pretty much for free. And notice that nothing happens because I'm not waiting for the result. So the simplest thing you can do is actually sleep for a moment, which is not the best thing to do in test, but I'm going to show you how RxJava makes testing asynchronous code insanely simple in just a couple of minutes. So let's run it, and you can see that both of these observables actually started at the exact same time. I'm going to run it again. So they started at pretty much exactly the same instant of time. They were both done, and we got in the events the moment they were actually arriving, which is pretty cool because it makes concurrency very declarative and very simple. So let's try another example, which is like completely independent from the previous one. Imagine you have two cache servers. Cache server, yeah, I happen to have a class here. All right, so one of them is in Europe, and the second one is in the US. And they are somehow replicated with each other, which means that whatever you put in one cache server, sooner or later is available in the second cache server. And when you're writing a client, you don't really want to guess which one is the closer one. You just want to get the response from the one that is closer to you, and discard the second response because it might be further away, right? You understand? So you have two cache servers, and you want to ask both of them and just get the fastest result, right? Okay. Okay, so how would you do it in normal Java? Well, it would involve like completable futures, blocking, waiting, maybe zipping or whatever. So what can we do? So we have a method findBy, which returns a string, and I happen to already have RxFindBy, which returns an observable. So let's just call both of them. And both of them will return an observable. So this is like EU observable, and the second one is US observable. Nothing happened yet. Tells me that I'm using a wrong key type, okay? Nothing happened yet because these are just observables, so we haven't subscribed to them. What I can do at the moment, I can use the exact same operator as previously, but just a static version called merge. So EU observable, US observable. At this point, I have an observable that's going to emit two events. One, when one of the cache servers returns a response, and the second one when the second cache server returns a response. Get it? So you have like two streams that are both emitting one event at some point in time, and then you are merging them so that you're going to get two responses. One is faster, and the second one is slower. So since I'm only interested about the first one, what I can do, I can say simply first, and that's pretty much it. So the second event will be discarded, and all I get is an observable that returns just one result, whichever was faster. So that's
It does discard the other one.
It does discard in a way that it no longer like listens to a second observable. It will also, the process is actually called unsubscribe. So it will unsubscribe from all the other observables. So if the first observable returns something, it unsubscribes from the other, and it's up to you to handle the unsubscription. So for example, you can terminate connection, you can release some resources, and so on and so forth. RxJava won't do it for you because it has no idea what you're doing underneath. All right?
But will it do it in a synchronous way? I mean, what will happen if first received and start up subscribing, and meanwhile the second event is received?
Yeah, so it's fully thread safe in a way that even if these two streams are giving you the event in the exact same moment, you would still get one of the events, and the second one will get discarded, and unsubscription will happen. So it's both asynchronous and entirely safe. So you are guaranteed to get exactly one event.
Then it means some blocking as well.
No, because this is still an observable. This one is non-blocking. It basically means that the first operator, or the merge operator to be precise, subscribes to both of these observables in an asynchronous fashion, and whichever observable emits an event first, it's going to be passed down in an asynchronous fashion.
Yes, but the turning first event should be somehow transactional process. So I need to get an event, return it, and unsubscribe. What will happen if I will get an event, and before I will unsubscribe, second event will come, and I will not be aware of the fact that first event is already there. I mean, this small part should be synchronous. Otherwise, you cannot guarantee that it will work as expected.
Well, in this particular case, you don't really care because you just get 2 cache servers and you get a result from one of them, and you don't care that the second one also returned a response because you don't care. You get the same response from both of them. So what's the point? I see your point that you might get a situation where you haven't managed to subscribe yet, but in this case, you should probably listen to all of them just to make sure you're not missing anything. But blocking in any way in RxJava is actually discouraged because it's supposed to handle concurrency for you. All right? Okay. So let's make it something a little bit more enterprisey. So how many of you know Camel or at least JMS? Fantastic. So if you don't know Camel, it's a nice framework. It has so-called components that allow you to connect to hundreds of different platforms like your mail, FTP, SSH, JMS, file system. Pretty much every single system you ever integrated with is somehow supported by Camel. So I'm just going to give you a very short introduction to it. So just to avoid any other framework, I'm going to start Camel manually, so it's called default Camel context. You don't really have to know how Camel works. Just assume it's something that can connect to various things. From the coding perspective, it's just I think Apache Camel, and then you have ActiveMQ Camel because we're going to do a demo with ActiveMQ in a second. And that's pretty much everything you have to add. All right, so we have this Camel thingy. And now the cool part about RxJava is that it's actually quite well established in the industry. So for example, you have Reactive Camel, which is part of the Camel distribution. RxJava is also supported in many, many other frameworks. For example, the official CouchDB or MongoDB drivers, client drivers, RxNeti, all of these natively support RxJava. So you can find RxJava in many, many different places. All right, but coming back to our Camel example, what I'm going to do right now is that I'm going to connect to ActiveMQ and just try to read some message. So for the people, so for those of you who don't know what ActiveMQ is or JMS, it's basically just a server standing somewhere to which you can connect and send messages, or you can connect to that server called a broker and you can receive messages. So it's basically a queue in a distributed system. But I guess you all know what ActiveMQ is. So what's going to happen right now is that I can say reactive camel to observable. And now I provide a string which is supposed to describe whichever system I'm trying to connect to. So I can do ActiveMQ. I'm trying to connect to a queue, and let's come up with some name, for example, Devternity. All right, this basically means I want to connect to ActiveMQ. I want to start receiving messages from ActiveMQ, and I want to get these messages in the form of observable. You see, so I actually get an observable of message, and this message is some generic camel type. So let's keep it this way. Or actually, I want to inline it back, and I'm going to make one more transformation. So message itself is actually a JMS message. What I actually want to have is the body of the message. So I can do message get body. And once again, this doesn't block. It's just an on-the-fly transformation. So whenever a message appears in the message broker, I'm just transforming it. So here we are. And at the very end, I'm going to do subscribe this print. So if we have some time, I'm going to introduce the toBlocking operator, but for the time being, I'm just going to sleep for a while. Remember that RxJava is non-blocking, so once I execute it, nothing's going to happen. So I'm going to run it first. I don't have ActiveMQ running. By default, it should be on localhost. I'm running a wrong test. By default, it connects to ActiveMQ running on localhost. It's going to give me a warning in about 2 seconds. Yes, that it's not capable of connecting to ActiveMQ, and that's actually okay. Let's turn it off. I'm going to run ActiveMQ for you right now, and I happen to have it somewhere. So in ActiveMQ something something. So ActiveMQ is basically just a Java application. You should see the terminal as well, I hope, even though it's blinking all the time. I think the blinking increases in frequency. All right, so let's just start it very, very fast. Okay, starting up an ActiveMQ console, and ActiveMQ is very, very nice because it actually has a web UI. Web UI looks like this. And you can see I can look at all the queues. I think I have one queue from a previous demo, let's just delete it. So as you can see, there are no queues in ActiveMQ at the moment. The way ActiveMQ broker works is that once you connect and start listening to a queue, this queue is automatically created. So no queues yet. My ActiveMQ broker runs. So let's try this demo again. And this time it's successfully connected, which is really cool. And it's also really cool because if I look, for example, here and refresh it, we see that we have a devternity queue. It's the same name as we specified here. It already turned off, so let's make the sleep longer. You can see that there's already one consumer, and this one consumer is our application, our RxJava sample code. And the thing what I'm going to do for the demo purposes is that I'm actually going to send a message to this queue. So I'm going to make it a little bit smaller so that you see everything. And on the terminal, once we actually receive a message from JMS Broker, you should see a message saying that we received a message. So the setup is as follows, for those of you who don't know JMS or ActiveMQ. We have a server that runs on localhost on port 8161. This server has a queue, and we're going to send a message to that queue using this admin interface, and our tiny RxJava code, literally that is everything you need, our tiny RxJava code is going to receive that message using an observable. So let's run it right now.
The message is auto-acknowledged, right?
Yes. That's actually a very good question. So the question was, is the message auto-acknowledged? It actually depends on how Camel works, not how RxJava works. And yeah, you have to look at the Camel documentation because our reactive Camel is a wrapper around Camel. Okay, so let's just call it hello devternity. And it's shut off in a second, so let's just make it... Okay. So here we have this application, it runs, and now I'm going to send a message. So what I want you to look at is actually the bottom of the screen where we have a terminal. Once I send a message, which happens precisely now, you actually get JMS consumer, blah, blah, blah. Yeah, it's hello devternity. So we actually got the message. Of course, I can send these messages as many times as I want. And it should still be working. Here it is, sent to. So that's probably the shortest piece of code you would ever find for integrating with JMS. Anything else? Of course, assuming the fact that you're adding like 10 megabytes of dependencies with Camel to your application, but still it's short. All right, so we got the second message as well. What's really cool about this integration is that you don't have to use the ActiveMQ scheme. For example, I can say file, and here I pass a random directory. So, all right, just like that. I don't think I have this directory right now. Let's just turn it off, ActiveMQ. So it was temp, and I'm going to create this directory. So devternity. So what's going to happen right now is that just by, yes? Thank you very much. It wouldn't work without it. Devternity, great. So rather than using ActiveMQ scheme, I'm going to use a file scheme. And the rest of the code is exactly the same. So still I'm just like, I'm just going to remove message get body. I don't think you see anything. So we're just going to restart the HDMI cable, hopefully. So what's really cool about ActiveMQ is that I think it's blinking. Okay, I'm just going to hold it like here and code with one hand. All right, so the really cool part about the RxJava and ActiveMQ integration, or sorry, the Camel integration, is that you can pretty much put any system you want in this place. Doesn't work at all. I'm just going to try a few more times. You can put pretty much any other integration, so you can put SSH, SFTP, file, whatever you want, and you're still going to get the exact same consistent API. Never happened to me before. All right. I'm just going to talk for a while and maybe people like cool down. All right, any questions so far? I'm really happy that you're actually asking questions along the way because it makes it a little bit more interactive.
Actually, we do have some questions on Slido. But
okay, go ahead.
Yeah, about the example 88, how is that example different if we implement it using completable feature?
It's not much different. So here's the example. Once you can actually get away with all the blinking. Good. good enough. So obviously you can use completable future. It would be nicer if it was actually a stream, so if you would get more data. And the API is also nicer because with completable streams, no, this is impossible to look at. With completable future, you could actually, the API is not so nice because you get arrays and all the API works with 2 values or an array of values. So I'm trying desperately to get this working. And we're jumping even more. Any questions to Camel integration in the meantime? Yep.
Can completable feature do Camel integration, by the way? Because completable feature, I believe, only can answer to one message, and that's it, and it's gone. But this one, reactive, can just start a stream and then just listen all the time.
Yeah, so it wouldn't make much sense to use completable future for Camel integration because that would basically mean that you can just receive one message, and observable is like designed from scratch to get to receive more than one event. So it's a very nice abstraction to.
So they are actually different.
You might say that observable is actually a superset of completable future because you can treat an observable as a completable future, but not vice versa. So because it's a multiple values.
And can you subscribe more than once to this?
Yes, absolutely. So if you subscribe more than once, yeah.
Is it possible to somehow
I don't know. I'm just gonna.
a database table and somehow monitor inserts of line?
That's a hard question because that would mean that you somehow have to like be notified from the database that actually something changed. So you would have to like constantly look at your database, or I'm just gonna change the. Okay, great. I just changed the resolution. Let's start it over. Okay, thank you. So coming back to your question, which I was answering being really nervous. So you don't really have any mechanism in a database for being notified about new records. There's, excuse me?
Does Mongo have observables?
Mongo has observables, but more in the sense like you ask for some data and you get an observable back, but it's not active. It doesn't stream you new data, as far as I know. Alrighty then. So you can use a file. You can use SFTP, for example. So you can pass SFTP something here, and it would still work. And pretty much you can integrate with any system you want, and you can still get this consistent observable API, which is a really fancy way of integrating systems. All right, let's keep it with the ActiveMQ part. And what I want to show you, which is really cool in terms of testing asynchronous code. So let's assume you have a very slow sum method, right?
Are there any other SOAP services except for this one?
Yeah, very good. So, and it returns a big decimal. So it's some service that returns data, and it happens to be really slow. So what's going to happen is that I'm just going to pretend that it returns big decimal 10, but it's really slow. So I'm going to delay this event by, I don't know, 10 minutes. So it's pretty much useless, but this is just for the demonstration purposes, okay? In real life, you would probably mock this out in some sense. So what you can do is that we already know the timeout operator. So we can say, I don't want to wait for this service more than a second. Okay, cool. But also, I somehow know that once in a while, this method can actually return a value in a sensible time. So I want to retry. You know, actually, many errors that you can come up in normal life are transient, which means that if you retry, you would actually succeed. So our systems would work much better if we would just like retry an operation rather than failing immediately. So let's retry, and I'm willing to retry 4 times. This is the simplest way of using the retry operator, which basically means retry infinitely and immediately. So every time we get an error, we just retry instantaneously. All right, so we have retry, but I'm going to retry at most 4 times. If you need more advanced scenarios, for example, retrying with exponentially growing delays, you can use retry when, and then you can implement all sorts of strategies like first retry is after a second, then after 2 seconds, 4 seconds, and so on. This is totally possible, but let's just stick with this scenario. All right, so here we have our retry. Yes? No, it's not really a circuit breaker. It's just a retrying mechanism. You can use Hystrix for circuit breaker, which also has a built-in RxJava support. But this is just a retry mechanism.
But you're doing essentially the same. After 4 times of trying, you just fail.
No, not really, because circuit breaker cuts off the system if it fails too often. This is the core of the pattern. So if you keep calling very slow SOAP service over and over and over again, and it's timeouting over and over again, then you're applying a circuit breaker and you're not calling it anymore. But in this case, I'm just retrying with a timeout, which is like too little. All right, so we have a retry. I'm actually want to do some logging, so I'm going to do on error, and every time I get an error, I'm going to log it. And now be very careful. I'm doing it very, very consciously, very, very consciously. I'm not logging a stack trace. You see, I'm just logging a toString of an exception. Never do this at home. Okay, because you're losing a stack trace, which is a very good, with a very bad thing. Okay, so I'm logging an error, and in case of an error after 4 retries, I'm gonna explain it in a second. In case of error, I'm just returning a fallback value of, let's say, -1. So it's gonna be 1 negate. 1 just loved this API. All right, so here's what happens. We have a very slow SOAP service. And this very slow SOAP service, which was like retrofitted in order to work with RxJava, this very slow service has a timeout of 1 second, which means that if it doesn't succeed within a second, we're going to be emitting a timeout exception rather than just failing. Okay. Then we are logging an error just to make sure it doesn't fail, and we are retrying up to 4 times. So if the system if we get a timeout exception, we are trying to resubscribe to this observable and try to succeed the next time. And if after 4 retries, so in total after invoking the method 5 times, if after 4 retries we still get a timeout exception, we are just replacing it with a fallback value of -1. Just not to fail everything, it's like try catch and returning something in a catch statement, right? So that's pretty much it. And yeah, it might look fancy. You might think that it's actually a very clever piece of code, but that's not the point of this example. So how would you go about actually testing this? Imagine you have this code. It's either written in RxJava or maybe it's written with your own for, sleep, executor service, and so on. How would you go about testing it? So one thing is that you can use our utility. Do you know this tool? It's like a testing utility that allows you to run a Lambda expression over and over again for a fixed amount of time, hoping that it will succeed. So you can basically say, all right, here I have a test, and I'm willing to wait up to 5 seconds because I believe within 5 seconds this assertion is going to succeed, which is kind of a workaround, and your test is still slow. You still have to wait 5 seconds or whatever to get the actual result. You can use a Java time clock, which is a fake source of time. But yeah, that's still kind of a workaround. What you can do in RxJava, and this is probably a killer feature that it's really, really useful, is that RxJava entirely abstracts system time. So rather than using a so-called default scheduler, I'm going to use a scheduler called test. And the test scheduler gives me entire control over how the time flows by. So what's going to happen right now is that I will subscribe to this observable. Here it is. Here's my observable. I'm going to call it result. And this result, I'm going to do subscribe, and I'm going to use a test subscriber. So test subscriber is just a utility given in RxJava to make testing easier. Test subscriber, here you are. All right, but here's the cool part. So here's my subscriber. Here's the cool part. Since I'm using a test scheduler, which I passed in here into a timeout operator, this test scheduler has full control over how time flows by. So the timeout operator no longer waits 1 second on a clock. It actually waits until I manually advance the time. So what I can do right now is that I can say test.advance time by 4,999 milliseconds. And you know what? The test is now entirely predictable. So at this point in time, I can say subscriber assert no values, and I can say subscriber no errors. Because I know that after 4,999 milliseconds, the last retry, remember the method is called 5 times, and the timeout is 1 second. So it will take at most 5 seconds precisely. But after 4,999 milliseconds, nothing should happen yet, because we still haven't reached the last timeout. So here we have it, and now I'm just going to copy-paste this code. Now I can say advance time by 1 millisecond, and now I'm absolutely sure that I'm going to receive no errors because I replaced an error with this fallback here. However, I can make sure that the fallback actually works. So I can say assert value, and I can assert that this particular value was emitted. And what's cool about it is that obviously this thing doesn't sleep for 4,999 milliseconds. It just advances this virtual time, which basically means that the test is entirely predictable. It's not going to fail because your Jenkins is slow, or maybe it's too fast, or maybe there was a GC or something. This test, hopefully, is going to work, by the way. Let's just run it. Yes, it succeeded, and you can actually see all these errors popping up, but it succeeded. So this is just a log message we placed in the middle. So having a test scheduler and a test subscriber, you can actually test every single combination of, just a second, you can actually test pretty much any asynchronous code which relies on time and which relies on things happening in the future. This was the last example, and please follow along with your question.
These assertions, are they compatible with you?
No, not at all. You basically just say, here's my subscriber, which is a test subscriber, and they have their own set of assertions. So on a subscriber, you're asking, hey, subscriber, have you received this particular thing? Or, hey, subscriber, have you received an error? And that's pretty much it. In RxJava 2, there are actually more facilities for that, but you have to take into account that test subscriber is still asynchronous. So you cannot just say, give me all the values, because it's a little bit more complex.
So
okay?
It's simply impossible to use some mock-in features just to intercept those values, errors, etc.
You don't really intercept them. You just want to make sure that particular values came here, and you can mock different things in your application to make sure that whatever these mocks have returned was sent back to your subscriber. Okay? Okay?
So for example, in Camel,
Go ahead.
you put in your code this test scheduler in, so it looks like you are putting test code in your production.
Yes, and so the question was, how come I'm putting my test scheduler in a production code? Because this is kind of a production code, right? This would normally land in a production code. The thing is that this particular scheduler is actually a general purpose scheduler. So you can control, for example, I could put schedulers.io, or I could put schedulers from an executor, a normal Java executor. And it's actually a very good thing to make this scheduler customizable, because you are giving this code to a client, and the client might want to customize the thread pool. He might want to put more threads or less threads, or he might want to put some monitoring. So you're explicitly allowing the client code to modify the thread pool. And it's very useful because in a production code, you want to put different thread pools. In a test code, you want to replace thread pool altogether with a test scheduler. So it's not like I have to modify the production code in order to instrument it, because this type of config should be there in the first place. Okay?
A question?
I think you were first.
So if you're using in Camel like Quartz component, so it's the same approach that we can use. Like if you're, for example, scheduling something to happen every minute, some event to be triggered, then...
Yeah, actually you don't need a Quartz component in Camel, because you can basically say observable.interval, which is like the very poor man's scheduling. You can say interval every second. Let me just quickly subscribe to it, because we're just running out of time. So I can just say interval, and then I can subscribe to it. All right, and sleep for a second just to actually see some results. And the interval operator basically generates a stream of events, 0, 1, 2, 3, and so on, every second or every event you want. So this is the simplest way of just creating something that, I don't know, periodically checks for something, or yeah, you see 0, 1 every second. So here you can periodically run something, and there are different types of intervals as well. So this is the simplest case, and obviously it also works with a test scheduler. Yes.
It will stop on first error.
Yes, I mean this one will never stop on any error because it just generates subsequent numbers. But still, it will stop on the first error. But in this case, you can use various operators like on error, do this or do that, so resume or do whatever you want. So you can like fall back into a different observable, which is like maybe it's working. So in case of an error with one observable, you are switching to another one, which is a useful pattern. Okay, believe you had a question. Okay. Yes.
What can we use over HTTP? I mean, if I want to do, because this one is under the JVM, if I want to do something with integration between servers, how should be the...
Yes, I'm just looking for... So do you know Retrofit?
Yes.
This is an HTTP client, and it has a built-in support for RxJava. So in this particular case, I'm just calling this API from Meetup. I think it's configured here somewhere. Yeah, here you're just saying api.meetup.com. You're creating a class called an implementation of this interface, and you get an observable of something in return.
Okay, but in this case, cities is a list of cities.
Yes, it's basically an object that maps to a JSON returned from that API.
My question was on the server side, meaning can I transform a server to be reactive in the sense that I give back a stream? What can I use?
So if you want to use RxJava on the server and make it reactive in some sense, you can, for example, use RxNetty, which has wonderful examples. I have them. I don't think we have more time, but RxNetty has support for both clients and servers written on top of Netty, but rather than using callbacks, it gives you observables of byte buff. If you ever use Netty, byte buff is basically a chunk of data sent or received. So in this case, you can very easily build reactive servers that are operating at the pretty much socket level, and you just build transformations on top of it. So you have a stream of bytes, then you have a stream of strings, then you have a stream of HTTP requests, and it's very declarative, and it's just extremely fast. All right. One last question. Maybe something from Slido, or we don't have any time left?
Slide is empty, we don't have...
Slide is empty, and any other questions here? Yes, last question.
Spring didn't take RxJava library. Why did it take Reactor?
I have no idea, honestly. I mean, the lead developer of RxJava, David Karnok, is also a very active contributor to Reactor, and it seems like they're just like mixing ideas with both RxJava and Reactor. The thing is that Reactor is now Java 8 compliant, and RxJava is still compliant with Java 6 because it's used on Android, and it's much more popular, and it's much more mature. So maybe Spring just wanted to be a little bit more ahead of the curve, and they wanted to have a more modern tool as opposed to RxJava, which is really widespread at the moment. And I was showing you like Couchbase, MongoDB, Rx Android, and all this stuff. So it's much more popular at the moment. Okay, that was the last question. So thank you very much. I hope you enjoyed it.